Hello everyone, welcome to this video. In this video, we shall be looking at several problems on sum of special series. So let's start with first question here. The question here says we need to find the sum up to n terms of this given series, right? The series is given to be 5 plus 11 plus 19 plus 29 plus 41 and so on. And we need to find it up to which term. Say this is a1, this is a2, this is a3 and so on up to an. We need to find the sum up to n terms, right? So clearly you can see this series does not form an arithmetic progression, or it does not comes under the category of geometric progression as well, because 11 minus 5, what is it? It is 6. What is the next term? 19 minus 11, how much is it? It is 8. And next we have 29 minus 19, which is equal to 10, and so on. So you see these differences, they are not constant, so this does not form an arithmetic progression. Similarly, when you divide 11 by 5, this is not equal to when you divide 19 by 11, which is further not equal to 29 divided by 19 and so on. So therefore we also do not have a constant ratio here, so therefore it does not form a geometric progression as well. So in this case, what can we do? We need to find a pattern in order to solve this. One thing. Another thing, we can make use of the nth term. Do you find a pattern from which you can calculate what is your nth term here, or you clearly or do you see any other kind of pattern apart from calculating this an? So this is the thing that you need to look over here. So here you can very clearly see the differences here, they are in AP, right? So what we can do, because the series is not in arithmetic series and in geometric series form, so what we can do, we can calculate an by and we also observe that these differences, they form an AP. So let's see how easily how we reach at this thing while evaluating an. So in general, in such questions, what we do, we use this kind of procedure in order to calculate an. What is that procedure? Now here we wanted to calculate Sn, which is this thing. So what we can do, we can subtract Sn from Sn. So this is your Sn, right? Subtracting Sn from Sn, so basically subtracting this thing from itself by shifting it a place to the right. So that means writing Sn on the left hand side as such. This is nothing, and we are writing the right hand side series below 11, starting from 11. So below 11 we are writing 5, below 19 we are writing 11, and so on, right? So you see whole of these terms, they are shifted one step to the right, and then after writing it like this, then we are subtracting both the terms. So when you subtract them, you have Sn minus Sn, right, which is nothing but 0. Then you have 5 as such, so 5 minus here, it is nothing, so you can write 0. So it is 5 minus 0, which is 5. Then you have 11 minus 5, right, it is 6. Then you have 19 minus 11, then which is 8. Then you have 29 minus 19, which is 10. And you keep on doing like this. At the last we would have an minus 1, this term, and the last term would be minus an. This would be alone, right? Okay, so after having written these terms and after subtracting them, we have 0 here, 5 here as such. Then computing all the terms here like this, we obtain this expression, correct? And the last term here becomes n minus 1 terms. We are taking this thing starting from the second entry to the nth entry. So this is second, third, fourth, and so on. This is nth. So if we count from 1, 2, 3, 4, so this term, last term would be n minus 1. So we will go up to n minus 1 terms, and this minus an would be as such. Now from this expression, by looking at this expression, can you evaluate what is the value of this an? Yes, we can. We can shift this an to the left hand side so that we have an here and all the other terms as such. Now you see in the bracket we have an AP with A as equal to 6 and D is equal to 2. So we can utilize the sum of calculating the sum of first n terms of an arithmetic progression. So what is the sum here? You know the sum Sn is given by n by 2, 2a plus n minus 1 times of t. So instead of n, we are writing n minus 1. So everywhere we are writing n minus 1, and this is our formula. Here we can substitute the value of a as equal to 6 and d as equal to 2, and we have this thing, correct? Now you can simplify the terms, right? You can multiply the terms and then evaluate, open up the brackets and then solve, right? You can solve for this term, you have this term, then you can further multiply the terms, simplify, and then you have this quadratic equation, right? And so you get the value of an. However, in the question we were required to calculate the value of this sum Sn. So how can we calculate that? By the definition, you know what is Sn? Sn is nothing but the sum of first n terms a1 plus a2 plus a3 plus so on up to an. So here we have summation an, where this n varies from 1 to n because we are taking this subscript from 1 to n only, right? So we can now substitute the value of an from here, which is n square plus 3n plus 1. Substituting it here at this value, we have this term, right? Now this is summation of this term. Now what does it mean actually? You can just extract and simplify this expression. So basically when you substitute the value 1 here, you would have 1 square plus 3 into 1 plus 1. This is the first term. When you substitute the value of n as equal to 2, you would have 2 square plus 3 into 2 plus 1, and so on. You keep on doing like this. So basically you can collect this term, this first term of all the terms, it would be 1 square plus 2 square plus 3 square and so on, right? And you can write it like this, summation n square, where n varies from 1 to n. The second, if you collect the second terms of each, so you would have 3 into 1 plus 2 plus 3 plus so on up to n. So you have 3 and all of them added together, so it could be written as summation n, right? And the last term of each term here is plus 1. So you have plus 1 plus 1 plus 1, right? How many times? Total n times. So in total it would be equal to summation of 1, which is nothing but n, correct? Now you know the formulas for square of terms and simple terms. So if you have 1 plus 2 plus 3 plus up to so on up to n, the formula here is n plus 1 divided by 2. And if you have the sum of cubes like this, so in that case you have this equal to n plus 1 2n plus 1 divided by 6. So utilizing these two formulas here and substituting their values here, we have this. You can then simplify the terms, take out the common terms, subtract the same terms with opposite signs, and further simplify the terms. At the end you will get this result, and this is what is your answer, correct? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.